As the world grapples with shifting from single-use consumption to a more circular-based approach to the products we use, dealing with our current waste stockpiles remains a huge problem and one where innovation is desperately needed. Researchers at the University of Queensland have discovered what's fair to say is a unique solution to breaking down one of the most difficult materials to recycle, polystyrene. To tell us more, we're joined by Dr. Chris Brinke from the University's School of Chemistry and Molecular Biosciences. Tell us about your team's amazing discovery.
Thank you so much for having me. Yes, what we discovered is that superworms, which are actually insect larvae, they can eat and live off polystyrene. And even more interestingly, we could show that if you give them only polystyrene, they could gain weight by just eating this diet.
What were the conditions that led to this finding? What different nutrition sources were offered to the worms in the study, and how did they react?
Yeah, so we knew already that insect larvae have very good mouth parts, so they're very good in chewing holes and destroying things. And there were earlier studies showing that small larvae like waxworms could eat holes in plastic bags and eat those bags. And that's why we decided to use the superworms, which are larger larvae. They're twice as large, about 5 centimeters. And we started our experiments. We didn't know at the beginning if they can eat polystyrene, and they were skeptical at first. But after 24 hours, they exploded and they started eating the polystyrene. And yes, we want to compare it. We had 3 groups, and one got the regular feed, the bran, one got polystyrene and nothing else, and the other group was the starvation group. And we could show that polystyrene allows the worms to survive and even gain a little bit of weight compared to the starvation group.
Metagenomics, it's a word that some of us might not know. Can you explain to us what it is and how it was used in this research?
Yeah, definitely. Metagenomics allows us to get access to all the DNA, in that case, all the DNA in the gut of the superworm, and we can then sequence it. And that allows us to see which microbes are there and what enzymes they encode. And that was very interesting to us because we want to see how the whole system works. So the worm actually eats the polystyrene and shreds it into smaller parts, but then the microbes in the gut, they help them to break it down further. And we could show with using the technique of metagenomics that those microbes encode genes that allow them to break down the polystyrene.
So this is effectively bio-upcycling. Could these worms tackle landfill to reduce the global stockpile of plastics that we cannot get rid of using our current technologies?
So we could use it in landfills. We could have, like, for example, gigantic worm farms. But what we are focusing on is actually on the bacteria, on the enzymes. So we want to have an artificial superworm, if you will, and then we grind the plastic, and then we produce those enzymes in the laboratory, and we add then the enzymes to the plastic and degrade it that way. And I think this approach actually scales better rather than having millions of superworms.
Can you tell us how long did the digestion process take, and how much material can they get through?
Yeah, it's actually fairly quick. So when they started eating the polystyrene, 24 hours later, you could see already that the feces turned slightly white. So they have eaten and digested polystyrene. And we could also show that microbes are already sitting on the polystyrene and degrading it. We haven't evaluated in detail what the volume is that they can degrade, but that's something that's in our list to detect.
Is using insect larvae like this a world first, or are there any other studies underway like this internationally?
Yes, I think there are more and more researchers looking into insect larvae because they have those good mouth parts, and there are so many species of insects out there. So I'm pretty sure there are other discoveries that are just waiting, and I know there are a few other groups also looking into other insect larvae and see how they can contribute.
Where to from here? It's obviously early days, but what needs to happen to ultimately farm these superworms to become part of the planet's bio-based recycling solution?
What has to happen is we have to characterize the enzymes better, the microbial enzymes in the gut. We have an idea of what they're doing, but we have to figure out under what conditions they work well, which enzyme does what exactly.